And I'm finding it
Think
really.
we're ready. Is it?
Okay, you're on.
Is this
Oh.
another one of those homogeneous isotopic days that we're going to get together? Hi, everybody. My name's Ronnie Heron. Your MC proudly inviting you on board our club's weekly Monday morning vlog. It's the SBAU Astro Hour. SBAU standing for Santa Barbara Astronomical Unit, which was formerly the Santa Barbara Astronomy Club, back when renowned astrophysicist Alex Filippenko was a young man, now in charge of UC Berkeley's Astro Department. He was a member of our club in the 70s, and he's returning to speak to us on Friday night, 10/3. That's October 3rd. Find out about us on sbau.org or find us headquartered. Get this. How about this for a headquarters, a place to meet? Your beautiful Santa Barbara Museum of Natural History. Whoa. Come join us for lots of fun. We're out everywhere. And here are the topics for discussion this week for program number 232, August 11th through the 17th. Got a busy early morning tomorrow. Venus passing just south of Jupiter. Perseid meteor showers peaking. The bright moon's going to be close to Saturn up in Pisces. And M11 this week, known as the Wild Duck Cluster, flies high in
Ooh.
Scutum tonight near the tail feathers of Aquila eagle. Maybe they're tall. We were watching, I think, this Saturday night at the Star Party. Just announced a possible jungle moon like James Cameron's Pandora in Avatar. It's a nearby gas giant. Wait till you hear this. There's a relatively rare astronomical event involving our coming new moon. We'll talk about this hour. What is a light echo, anyway, other than sort of a
Yeah.
reflection? And some of Saturn's shepherd moons and a special asteroid we're going to look at. Plus, this Chinese astronomer using our, well, Webb scope, I guess, looked into dark matter. Let's meet the men in charge here, shall we, ladies and gentlemen? The captain of the starship is Jerry Wilson, our beloved president.
Good morning. Let me do
Gonna
a
call-
shout out here to my sister Joyce and Riley and Calvin, my two grandkids.
Are they there with you, or you're just they're
No, no,
watching
they're
us?
watching on TV in their respective homes.
Well, good for them. Plus, maybe some of your fellow homeowners in the association out there. We had a little talk several weeks ago and
Yeah.
told them about it, and they wrote it down. We're going to watch us. Chuck McPartland is our outreach coordinator, and he's outrageously outreachable. Man is awesome. Pat is his wife, too. Pat Forgey's married to Jerry. Pat McPartland is not only a merchandise manager for the club, but an incredible keep the books balanced treasurer. Joining us today, Tim Crawford, our resident lens and telescope expert,
Hello.
married to his wife, Karen. And of course, Tom Whittemore, who's married to
Morning.
Maureen, former Westmont College science
Morning.
instructor. We start the day, start each of these shows every Monday morning with some silliness to keep us in a lighthearted mood. Not that we need that because we're pretty lighthearted anyway, but it's always fun to have the silly science cartoons. President sent them all to us at one time. There's 7, came in one email. You got that covered, I guess, Jerry. You know how to do
Yeah.
that now, rather than 7 in a row, different emails. Here we go. This would be the chemistry, not a Christmas tree, but a chemistry. Is that some sort of a strange uh, crystal forming, you suppose?
Hexagonal branching.
Right.
Ah, see 6-sided stuff. Yeah, okay. Is that a real tree? A real picture?
I assume so.
Oh,
Looks like it's got thorns on it.
Yeah, you don't want to fall into that one.
No.
something
Yeah,
you find out.
one of my wife's bougainvillea plants.
Well, those are nasty.
Tell me about it.
Looks like this is going to be in order. No, this is the cat from hell. I got Emma and the dog and the new kitty cat. It's a Far Side cartoon and a little washed out, but you can still read it. Emma, hey, the
Oh, you
dog
want me
is.
to change it?
It's okay.
Oh,
If it takes a long time, we can live with it. He's hanging the cat upside down outside the window to make the dog go crazy and cry to get it, and it doesn't. It's just sort of ignoring it. There's a lot of YouTube videos showing animals getting together and rolling on each other, and dogs and cats playing and licking each other, and they're just cute as hell. There we go. Emma, that dog ain't going for the new cat. There's the new cat.
I think he might be suggesting that the dog tied the cat up, but
Yeah,
right.
that's what I get. Yeah.
Oh, I see. Okay, I thought he was trying to make the dog react. Got
Mm.
it. Well, it took a while for me to figure this one out too, or initially. Well, not too long. They're out digging for bones and they find something else. Paleontologist in the field says, or are we only interested in fossils, guys? Look what I found.
She found a caveman.
Yeah, that's good. That's got to be in a Spielberg movie. This one took a while and I had to look at it carefully. There's three of them. They're sitting looking supposedly through a one-way mirror, and the guy turns to each other and says, "You know, for crying out loud, gentlemen, that's us over there. Somebody's installed the one-way mirror in backward." And
Uh-huh.
it's the primate studies. Like
Someone
putting,
at yesterday's solar event in the museum asked me what all the tapes were on the patio. And I told them that the contractor had misinterpreted magnetic north for real north. And so they were correcting it by marking the cardinal points to help us set up our equipment out there. And
oh,
for
is that
some
right?
reason, they were very fascinated with that explanation and they photographed all the cardinal points.
It was also, I think it's set up to act as a sundial.
It's a sundial, Chuck.
Yeah.
And
But it
where
helps me line up my scope because I can't find Polaris in the daytime.
Yeah.
Uh-oh.
Somebody
Okay,
should set this once they decide on it. They should set that with putting inlays of brass in there.
Yeah.
That would be nice.
Yeah, really
Jerry,
nice.
Jerry, I'll let you read this one to us. It looks like the alphabet's mostly up there on the wall.
At first, there were only 25 letters in the alphabet. Nobody knew why.
And there it is. Why?
And you see Y, W, X, Y, Z is missing.
Why? That's why.
There's a similar Christmas card with Noel.
Noel, right.
Oh.
Well, there are some
They,
unnecessary.
At
There are
work
some,
at Santa Barbara Research Center one year, they said no religious symbolism for Christmas could be displayed in your office or in the halls. And so
no holly.
someone made the international sign for no, the circle with the line in it,
Yeah.
superimposed over an L.
Yeah.
Then there's the fish on the car bumpers. This is Calvin and Hobbes. Looks like Dad is lecturing the kids. Says, you know, son, before there was television, you kids actually did things on nice days like this. And the kid says, times sure change, huh, Dad? Tossed out by Dad, and then he's sitting with his friend Hobbes. Ever notice how Dad brings up subjects he doesn't want to talk about? Huh? That's true. I find myself doing the same thing. All right, this one might take a little interpretation. Everything's being said by the little dinky dinosaur to the left, right?
Yeah.
Wow, well done. You sure scared me. You should pat yourself on the back. Oh, right. Yeah, that would be the late great Sarcastosaurus, which went extinct. They have names like that. Every year there's new dinosaurs that I didn't grow up with. You know, Brontosauruses
They're
and
finding new
T-Rexes.
ones all the time.
I know it. Just tack the word saurus on the end of something, and this is just as good as one. Sargassosaurus. Okay, we got stuff to talk about. Cutting edge cosmology here on the Astro Hour, gentlemen.
And cutting edge morning stuff. Did anybody see Venus and Jupiter this morning?
I was sleeping.
No, I was sleeping.
It
Oh,
was
5 o'clock,
overcast.
wide awake, 5 o'clock. Really beautiful. Like two
Really?
eyeballs. Two eyeballs in
Wasn't-
the eastern sky.
It gets even better tomorrow morning.
Okay. It was pretty good.
Wasn't overcast where you live, Tom?
No, we don't allow it.
He gets a little above it.
Yeah.
I understand that's part of Jerry's homeowners association rules too.
Yeah.
Gotta have a clear sky.
So Venus must be in descending mode, huh, Chuck? Is that what's
Yes. Yeah.
yeah, must be. Yeah.
To
Okay.
move fast
So-
enough to change it that quick. Yeah.
Yeah.
Okay, this is tomorrow morning at 4 a.m. One of
Yeah, they were
Chuck's-
side by side this morning.
Yeah.
Side by side, like two eyeballs.
No
One bright
kidding.
one, kind of bright one.
And
Wow.
plus forget
Also
Perseus.
tomorrow morning, if you're looking east again at 4 a.m., you'll be in a good position to spot Perseid meteor showers or
Mhm.
meteors.
Yeah.
So, and fortunately, it's going to be very close to the full moon,
Yeah.
and
Or
so
Yeah.
that will interfere.
a bright
Yeah.
moon. Yeah.
Yeah, just
Yes.
another little comment. So I have a good friend. He gave a talk years ago at the club when he sailed in this race to Hawaii, and he navigated by Venus. Some of you might remember Steve Hodges.
Yeah.
It was some years ago. Yeah. Anyway, he and his daughter sailed to Hawaii recently, and then Steve, with another friend, is sailing back. Okay, and a few mornings ago, he texted me. And he told me that he saw Uranus come up, okay, ahead of the sun. It's kind of cool. So I said, Steve, those are dark skies.
Yeah.
So he saw Uranus because I said, yeah, it's in Taurus. Yeah, I can imagine.
That's one advantage of being at sea. There's no city lights.
Yeah.
Yeah, yeah. He was. He's going to end up coming into San Francisco probably within the week, is my guess. But
Okay.
he's quite a sailor. He's really, really good.
Where does he live?
Now the family's moved up to Eugene, Oregon.
Okay.
Okay, where he got his PhD, Jerry.
Yeah. Okay.
Okay. And isn't that where your son teaches?
Yes.
Yeah, okay. Yeah.
Pat used to be a next door neighbor to Steve back in the 90s.
Yeah, on La Combadura.
Yeah.
Yeah, uh-huh. Yeah.
Yep.
Mhm.
Normally we
Okay.
can't see Uranus.
Well, it's tough. You have to have a real dark sky. I think it was hovering right around 6 magnitude, which it really strains the depths of the sky. Okay. It might have been even in the high fives, like 5.8 or something like that.
Would definitely be a little dot.
But he saw it, he saw it come up, then he saw Venus and Jupiter come up, not in the alignment you see here. Okay. Um,
Well, what about Neptune? Is that ever seeable?
No.
Not with your eyes, but we've seen it a lot at Westmont, the telescope and the 8-inch.
Okay, got it.
I've seen it in mine. It's not particularly exciting.
Yeah.
Okay.
Well, this is Chuck's favorite kind of night sky map.
Oh, that's nice.
Well, this is better.
This
Yeah.
is a past a photograph of the let's
Oh,
see.
the meteor shower.
Mhm.
Yeah, the Perseid meteor shower. Oh, it doesn't say when it was taken.
And you
But,
can see Perseus there on the left, Jerry, on the left.
yeah.
Yeah, that's really something.
Just up and left from the tree there.
Right. So those
Mhm.
must be what, the Pleiades down below
Yep.
in the crack?
Yeah.
Just to the right
I
of the
think
tree.
so.
Yeah.
Okay.
This is taken at a place called Westgard Pass. It's very familiar, but I don't remember where it is. Probably in Arizona, it looks like.
Okay.
It's an arid place. Few clouds in the sky, Earth atmosphere clouds, not
Yeah.
nebula.
Mm-hmm.
And something over here, probably a planet, would help to know when it was taken.
That might be
Good picture, though.
Capella.
I think it's Capella too. Yeah, I think you're right,
Okay.
Chuck.
Yeah, it looks like these are all coming from right about here.
Mm-hmm.
And Perseus is just to the right.
That's
of
it.
that.
Okay.
Oh, no, not to the right of the frame, but to the right of where your cursor was.
Yeah.
Oh,
Way-
right
way
there.
in
Right
there.
there.
Yeah.
Yeah.
The lawn chair, right, Chuck?
Yep.
The lunch here. And that's just what you need to watch the meteor shower.
Yeah.
Well,
A
do you ever
lawn
see
chair.
four?
Yeah.
Do you ever see four of them at once, or is this taken at a different time?
This
I
is this is probably a mosaic of several, but
Yeah.
back, back
Yep.
back around the turn of the century,
You could see
there
them.
were some showers, especially the Leonids, that you could see 10 or 15 at any given moment.
Wow.
Wow.
I've never seen a shower like that.
Oh, it was fantastic.
You know
Just
what it
don't make
reminds
yourself too comfortable on the Chase Lounge. I tend to fall asleep.
Yeah. It looks like Andromeda up there. Oops. Looked like Andromeda up on the top there.
Oh, yeah.
Right there.
Yeah.
Yeah.
It's because you can see Andromeda's flowing robe coming down. Okay.
Mhm.
Huh.
So I'm surprised we don't see M33. Because that would be just on the other side of
Yeah,
the,
but there's clouds
We're right
there.
behind these
there's
clouds.
clouds. Yeah. That person could easily see through 33 without the cloud.
Okay,
So peak tomorrow.
Mhm.
I think it peaks on the 12th, 13th night. So tomorrow night and Wednesday morning.
okay.
And then every year in mid-August, we go through that
Yeah.
particular
Around the
radio.
12th. Yeah.
Okay.
Here comes the Tim favorite.
Oh yeah.
So this is the square constellation of Scutum.
Mhm.
That's the territory it could negotiate. This is the construct, the stick figure for the constellation,
Yeah,
and a
shield.
globular cluster right in the middle of it. M11 is over here. It's an open cluster called the Flying Duck Cluster, Wild Duck Cluster.
Mhm.
Wild ducks.
Duck.
Yep.
Yeah. And that is got its name because of the guy that discovered it, William Henry Smythe.
Yeah.
It looked like a flock of ducks in their V formation.
He didn't
I
discover it, but he wrote a series. He was a Reverend Smythe, and he wrote
Yeah.
a series of observational handbooks for people with small telescopes in the late, I don't know, mid to late 1800s.
Yeah. Yep.
Okay.
Saturday night, I tried to go for that, and the sky was so bright that I couldn't see the two indicator stars I used to find it. And it's the one that's down. M11 is right between two brighter stars, and you can I don't know their names. I think one is like I can't remember what it was, but there's a little some kind of symbol right next to the one on the right. It's the end of your stick figure there, that
Yeah.
one there, and then on the other end there's another star. No, over to the left.
The end of Aquila.
Yeah, the end of Aquila, and it's not that one. The one up above that one, and it turns out that M11 is right between those two,
Oh,
Okay.
yeah.
That's
and
Good
good.
observation.
it's a really nice way to find it because otherwise you might spend 20 minutes trying to search around for it.
Yeah.
But like Saturday, it was so bright that I couldn't see those, and I was just like wandering around, and finally had to apologize to people and said, "Well, we're not going to find M11 tonight. Let's
That's a
do
pretty
something
bright
else."
sky because M11 is easy to find in my view.
Mhm.
Yeah,
Is
well,
it?
it was full moon and there was some smoke. So
Oh,
Very, very difficult. Couldn't see these star indicators for me. One in a darker sky, when I see these two, I literally go to it now, and it used to take me forever.
mhm.
Well, do you have a close-up of it?
coming
I
up.
didn't put that in there. We've looked at it so many times. I can get one if you want to see it. But the reason this is up here is because it's near a very interesting variable star called RV or R Scutum.
Mhm.
So let's see. This is a close-up from a planetarium program of
Mhm.
the flying or what is it, the constellation. And R Scuti is this red star right there. M11 is right here.
Mhm.
So this is the beta and the alpha star for the constellation. But this is the variable star here. And it is a weird variable star. It's not an orbital, eclipsing variable.
Mhm.
It's labeled an irregular variable. I was hoping for more of a detailed explanation of why it's irregular. But this is light curves for this generated by variable star observers. There's different figures here depending on who recorded the magnitude at the different time.
And Jerry, there's a subclass of Cepheid. It's called Delta Scutis. Okay. That might be in your picture on the previous frame. Delta Scuti.
So this is a Cepheid variable?
No.
Oh, no. I'm just going to say that
There's
Oh,
delta
boy.
right down there.
there it is. Delta Scutis, that's a famous subgroup of Cepheid variables. I
Okay.
think they're fairly short period. In other words, not 120 days like, some of the big members, but more like maybe over the course of a night or two. Delta
Yeah.
Scuti. Yeah.
But those are regular variables. This is an irregular variable.
Boy, is it. Look at that.
So it's kind of unpredictable.
Yeah, it looks like somebody sneezed on that chart.
Yeah. So this is from 2009 to 2010. So it's over 18 months from February 9 to July 2010.
You can't
And
predict what it's going to do.
it goes between magnitude 4.5 up here and magnitude 7.5 down here.
Boy,
Each one magnitude is a 2.5 is 2 times in brightness. And so that's quite a change in brightness.
Right.
So my guess would be that it's got clouds around it and it's shining through dust and gas.
And Richard on YouTube is guessing that it could be lensing around the occultations or occlusions.
No.
Okay.
Those are one-offs.
Yeah.
Lens
Or
event.
or they're regular if it's a planetary thing.
Yeah,
No, this
you
is
go for just the two low dips there. You're looking for periodicity. You're talking roughly a year.
it
Yeah.
said 140 days for a period in the write-up, but also
Okay.
you can see it mentions the spectrum has titanium oxide bands. So it's more like a case when it swells up and the surface atmosphere far from the center gets cooler, that you get the formation of molecules that then block more of the light coming out and it starts to get dimmer. So not only dimmer from the temperature, but dimmer from the formation of molecules that are more opaque.
Yeah,
Okay.
the opacity.
So we never know what it's going to do.
Well, we have a rough idea of this 140-day period, but yeah,
It's going to do this.
And it's not a white dwarf sucking off of its big red giant brother. It's not one of those.
No.
Okay.
Yeah, I mean, again, just giving a rough idea of the swing and magnitude there. Like Jerry mentioned, about 3. That'd be 2.5 to the third power, which is ballpark, 14, 16, somewhere in there.
Yeah.
The brightness.
Huh.
Okay.
R. Scudam and his orchestra.
Now this one is our nearest neighbor. It's a multiple star system, actually a triple star system. Alpha Centauri A and B and Proxima Centauri that
Okay.
are gravitationally connected. And there are a probable, it's not absolutely 6 sigma confirmed, but the Webb has been looking at the system Alpha Centauri A, which is blanked out here with an occultation disk in the picture. And it's got this lobe over here, which is believed to be a gas giant planet.
Wow.
With when you have several objects orbiting each other, it's very easy to get the statistics on the objects, such as their obviously distance, but their mass and their period. So that one gives this a mass roughly of Jupiter. So it's believed to be a gas giant. And there was the article on the web, on the space.com, I believe it was, said that this was like, this was reminiscent of Pandora in the James Cameron Avatar films, which incidentally orbits a gas giant called Polyphemus.
That is around Alpha Centauri A. Yeah.
Yeah, yes, right. This is not, it's still being debated. But
I think,
the
article, they did a follow-up and didn't see it, so it's a lost planet.
Hey Jerry, I'm confused by this. I know you have the Alpha Centauri and then Alpha Centauri A and B, but the third image, where
That's Alpha Centauri A and the proposed planet going around it.
But there's a third star, the Proxima, right?
Yes.
Yeah, that's not shown in any of
shown
it.
here because it's farther away.
So the third image is that really the square kind of,
Yes.
okay,
Yeah.
okay,
This square is this square.
okay, good. Okay, I didn't get that. Okay.
Yeah. See, each one, it has, for this one, see, there's a little teeny square in here because this is the star Alpha Centauri. And you see these lines going up indicating that that little square is this square. And this square has lines going up or shading going up indicating that this square now is expanded to be this square.
And then they have an occulting disk to block out the brightness of Alpha Centauri A.
Right, right.
So,
Now,
so
you
it's a
can do
three-star.
this for, what's that?
It's a three-star system, and these are the two big ones, right?
Yeah,
That
these are,
orbiting-
yeah.
Okay.
And Proxima Centauri has planets, exoplanets.
Yeah.
Now, you can do this with your own telescope visually, not on this star, but on stars that have a close, faint companion like Sirius. You can see that's the dog star. You can see the pup, the small star that's rotating around it, its companion, by taking a piece of fishing line and stretching it across your eyepiece in the focal plane of the eyepiece, and then looking at the star, and you maneuver your telescope so that the piece of fishing line blocks the bright star.
Huh.
So that light will be blocked, and then you can, if it's rotated the right way, it takes a little bit of work, but you can actually catch a glimpse of the pup star. I
Huh.
think it's getting easier now because the separation has increased since I started doing it in the 60s.
I think it reached a maximum a couple of years ago. It's decreasing again.
Okay.
I wonder if you could use a finder eyepiece, with the crosshairs.
Yeah, that's anything with it in there. Some people use a blank piece of aluminum foil stretched over with a sharp edge stretched over half the eyepiece field of view.
Huh.
And then you just maneuver it so that it blocks the main star.
Interesting.
Finder might not have enough magnification, Tim.
Okay.
Yeah.
Okay. That's interesting. Nice, nice tip.
Well, can I ask a stupid question? If I missed something, forgive me in what you just said. The two big ones we were looking at, it's labeled a binary. On the left there, it says a binary. Does that mean the two big ones are orbiting each other and Proxima,
Yes.
the little one, is orbiting both of them?
Yes.
Is that how it's working?
Yes, yes, and yes.
Oh, and Proxima, the little red dwarf star, is closest to us somehow by.
Yes.
Right now, yes.
Okay, got it.
Okay.
If I'm not careful here, my kitty's tail is under one of my wheels.
Ooh.
I gotta be
If
really
you make a
careful.
misstep, we'll all hear it.
Yeah, yeah.
See a Gary Larson cartoon come to life right on our screen.
This could be
Yeah.
exciting.
Well, the other day, about a week ago, I accidentally stepped on my cat's tail.
Yeah.
She turned around and looked really pissed at me. No mistaking her thoughts.
Yeah.
So anyway, you asked what the hell is an light echo. It's just like
Yeah.
a sound echo. This is where there is a bright light that is not a constant light. It's something like a supernova that goes off. And so
Huh.
it's a flash bulb. And the light comes straight to us. That's the shortest path. So we see that light first. But then there's other clouds out here, and the light goes out and it bounces off that cloud or off this cloud, and then it goes to us. And these are longer paths, so they take longer. So what you see is that these paths, you see the light move out into this cloud, and you can see all of a sudden a piece of the cloud that was dark is now illuminated. So you see something get brighter farther away from the star, and it creates dramatic effects.
Is it similar to gravitational lensing, or it's totally
No,
different
totally
concept?
different.
Not at all.
No,
Okay.
this is just the sound bouncing off the canyon walls.
Right.
So these are pictures of one of the most famous light echoes. This shows it on May 2nd. There's a star that, what was this? I think this was a nova.
Yeah.
one that-
V8 Monocerotis.
Right.
Oh yeah, yeah. And this is these are the clouds around it already that were already there. Just the light is now illuminating them. And then same year in September 12th, the light has got out here farther. And on October, it's more. And in December, it's way out here. And in February, the next 2 years later, it's reached the extreme outer limits of this gas cloud, which is being hollowed out by solar winds. So you can see the gas that's being blown away.
Looks like we're looking through the hole of a bubble.
Yeah, you are.
Can I
Are
ask a question referring to the light echo? I think Richard wanted to know if those are calculable angles that you can
Those are what?
calculable angles
Yes, you
and
can. Yes.
refractions.
Yeah, we know the speed of light. So essentially, you know the length of each side.
Okay.
So you can figure out the angle between them. So let me see if I can
light
get,
echoes? Huh.
oops. Let's see, get rid of that. Oh, that's right. I've got hang on, we're almost there.
Oh,
Can you see
great.
that? Yeah, this is another example of a light echo. As you see, a beam of a pulse of light is going through and illuminating different parts of this nebula at different times.
Hmm.
Now,
So it's common or it's not common?
it's not that common.
Oh, okay.
Let me just get one more.
Plus, they weren't seen, until fairly recently when people figured out, wait a minute, that's what's going on.
Yeah. And
Now that we've got things like time domain astronomy, you can spot more of these babies.
yeah. So this is a light echo. It looks like something out of a monster movie heading for Earth, but yeah. Now these are, you can get them in any wavelength. I think these are radio waves or X-rays.
This says infrared echo, yeah.
Yeah, infrared, yes.
And
Yeah,
it's
infrared
it's
echo.
running back and forth. So
Yeah, it's a loop.
yeah.
Yeah, I think it consists of 2 or 3 frames.
Yeah.
Okay.
Those aren't nebulae we're looking at.
Yes.
Well, they were, but there's the light is refracted and comes a little later from a
It's
different area.
reflecting off of them and comes a little later depending on the distance.
Okay.
And that's Cassiopeia A. That's
Yeah.
is that Kepler's supernova?
I think that's right. 1672?
1604, I think.
Oh, 1604. Okay.
And this is one in gamma rays, if I remember right.
Wow.
But we're not going to see it move. A Hubble telescope image. No, this is of a quasar that is producing a pulse of light. So, but no backup to make a movie out of it.
Would a pulsar have these light echoes?
Yeah. Except in radio.
Yeah.
You need something that's nicely radio reflective for it to hit.
Okay, Richard is asking things here, and I'm not exactly sure what he's talking about. He said, "Yeah, it doesn't seem you can predict the behavior of that." So he's still confused on the angles of the light echo I kind of suggested the radius of that, and
if you already knew the distribution of the clouds, you could figure out when you were going to get these pulses. And they did that with one. I'm mixing it up with a different light path problem. There was one that they predicted you'd see a fifth image of this supernova
Oh,
going off in a galaxy because of some lensing that was going on, and
right.
that's similar in the sense that it's a light path problem. It's not reflection as much, though.
So the light echoes a reflection, right?
Yes. And
Okay.
you'd have to know the configuration of the clouds around the object you're looking at to know ahead of time that you're going to see these light echoes. But once you see them, you
Oh.
can now figure out the configuration. And if you've got a repeating thing like a pulsar, then you can predict when you're going to see those things.
Oh.
But
The
it
trouble
makes
is that pulsars tend to be really short periods, so you'd be seeing it quite a bit, you know.
Richard, I hope you get it. I'm confused on I'm hearing him, but there's a little cork in my brain that's keeping it from getting through.
Well, okay, so look at this diagram here, and what you see is take the red line, right where it makes a sharp turn, you know, oh, there's a lump of cloud there, right at that bend,
Yeah.
okay?
Yeah, it's
Same thing
bouncing
for
off
B,
something.
for the blue path, you know there's a clump of cloud there. And so if you had known about those clumps ahead of time and you see A and it was a long enough distance there to get to the clump, then you could say, okay, pretty soon we're going to see an echo from B. And then, and a while after that, we're going to see an echo from C.
Okay. Okay.
but
Interesting.
there's enough reflectivity in those clouds to make it almost like a mirror?
Yeah.
Really? It's
Well,
a
I
bunch of
wouldn't say
gas
it's
and
as high.
dust.
It's as
It's not like,
reflective as a mirror,
yeah,
but
it's
it's
not like you're
reflective.
seeing the full brightness of the supernova or whatever,
Yeah.
but you are seeing a flat, you know, a smaller flash.
Richard says thank you, Chuck.
And we're not hearing from our young man in India today,
No,
I guess.
no, Astro Delhi hasn't been here for the last 2 weeks. He might be here, but he isn't signing in, so I don't know.
He'll sign in. All right.
Okay,
Fascinating.
next we come to something I'd never heard about called the
This
black
sounds a whole
moon.
lot like the blood moon nonsense.
Yeah. The Black Moon. Yeah, this is interesting.
So you have different types of black moons, and it's really a new moon, which is represented symbolically. I don't think this is a real picture of the black moon or a new moon. If it is, it would have been illuminated by Earthlight.
Oh, I
But
see.
I mean, the sun's light off of our oceans. But you can have a monthly black moon, a seasonal black moon, and it's good for stargazing because it's not in the sky, but any new moon is that way. But a monthly black moon occurs when there are two new moons in the same calendar month. Then the second one is called a black moon.
And
It's like a blue
if you
moon.
bring this up at an astronomy conference, you might just get a black eye.
Well, this looks like a full moon.
No, this is definitely more in the folklore department.
Okay.
Run.
This is a picture of the full moon that's been dimmed down.
Yeah.
So if you're looking at
Oh,
it as a new moon,
Well, it might have been taken during new moon when it was offset enough from the sun and
yeah,
earth shine, but yeah, that would be really tough.
yeah. The seasonal black moon occurs when there are four new moons in a single season, and the third of these four is called the black moon.
So that's very similar to the blue moon, the original blue moon.
Yeah.
And this other black moon, the monthly black moon, is similar to how people interpret blue moon sometimes now. So it's the same thing. And somebody said, "Hey, instead of dealing with full moons, let's apply it to new moons."
So this topic came up because a black moon will occur on August 23rd, August 22nd for us here in the West. This is a seasonal black moon in that it's the third new moon in a season with four new moons. They don't say whether it's astronomical or what was the other one type of season.
Well, it says seasonal. The
Yeah.
others are monthly or seasonal.
Okay.
The types.
Any questions? No.
Yeah, how do I get you guys to overlap and you've disappeared and I get a black screen?
You got a black screen?
Uh-oh.
Uh-oh.
He touched a button.
He did.
The red button.
Yeah.
Your
Okay.
system will self-destruct in 5 seconds.
I have an off-topic question.
Yeah.
Richard I think he wants to know, like on the moon, if you is, I think wants to know, is it possible to have a nuclear reactor on the moon? Wouldn't there
Sure.
be like a cooling problem?
Someone's planning on building one on the moon.
Yeah, there's a NASA proposal to put one on the moon.
Yeah. Welcome
Oh,
back,
okay.
Tim.
All you have to do is shade it.
Oh no, the Baron's gone.
Yeah.
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 All you have to do with a reactor on the moon is shade it because you don't have the problem here of a blanket of atmosphere that distributes the heat
Oh,
Yeah.
and holds it in. So once you got it in shade, it's going to be cool.
so it'd be pretty effective up there, huh?
Yeah, yeah.
Okay. Well, good question, Richard.
You need them on the moon because the moon is dark for half a month, wherever you are, unless you're at the South Pole or the North Pole.
Yeah, yeah. Oh, that's a great question. I like that, Richard.
Yeah, so this is a image of the near IR focal plane on the James Webb Space Telescope. And someone had the idea of trying to spot dark matter using this focal plane. And there was a bunch of calibration runs where they take what in photography we call dark frames, which means you want to characterize the because these detectors detect photons, but they're also electronic devices, and they continually run current through them, and they run it at different neighboring cells will be different resistance, so there'll be slightly different signals you get from each one. They want to calibrate that so they can subtract it out of their image. So they take these calibration frames and they wanted to see if there was any evidence for radiation interacting with the focal plane. So they looked at these these dark frames, which had a cover over it so that it wouldn't get any light. And it was done by a couple of people at the University of Science and Technology in China. They got time on the James Webb Space Telescopes, and they found nothing. So dark matter is still dark. There was no interaction, no identifiable interaction that they could find, which sounds like, even a no result is a scientifically valuable result. So that put constraints on the existence of dark matter that interacts strongly with ordinary matter. Now, we characterize dark matter as not interacting at all, but some theories of dark matter claim that it will interact weakly. And so they were looking to see if this puts an upper limit on how below which any interaction with dark matter will occur. It's not an easy thing. Questions? Okay. Moving on to the weird moons of Saturn. Now, this looks like something out of a B science fiction movie from the 50s.
It's a pelmeni moon.
It's a what?
Pelmeni moon. It's like ravioli, but that's
Yeah.
kind of the Slavic version.
Okay. This is one of Saturn's moons called Pan, and it is a shepherd moon. As Chuck points out, it's referred to as the flying saucer or the ravioli shape. And it maintains the shape of the Encke division in the
Oh,
Saturn's rings, and this is the subring in there. The central ringlet of the A ring's Encke division coincides with Pan's orbit, implying that this particular orbit is a horseshoe orbit. Now, if you
Horseshoe.
haven't heard of a horseshoe orbit, I looked it up quite a bit, and I didn't want to get into all that detail here, but it's an orbit that actually is a horseshoe. It doesn't go all the way around the object that it's orbiting. It's
Huh.
perturbed by other properties, and so it actually rotates around its own orbit, and it goes all the way around almost to connect with itself again, and then it backs up and goes back in there. So it describes a horseshoe shape in its orbit.
That's
That's
weird.
that's for the particles in this ringlet, not for the moon, not for Pan itself.
That's right. And that's where that ringlet is. That's a horseshoe orbit.
Yeah, and you can see there's a kink in it here, and then there's a couple of little kinklets, and but probably Pan is somewhere in between one of those, and so those particles in the ringlet kind of swap from the inner orbit to the outer orbit.
Huh.
They speed up, slow down as Pan goes by them. So
Now
And
you can,
does that clear the gap?
that helps
yes,
clear the gap.
it
Yes.
keeps it out of there. Yeah.
Huh.
These are nightmare homework problems in celestial mechanics.
Oh boy.
Trust me on this. And they ask nasty things. Once you get the problem solved in our three-dimensional space with inverse square law gravity, they say, okay, now make it inverse cube law gravity. And what's the shape of the orbit? Are there stable orbits and stuff? So you go back and do it again.
Advil time.
Yeah. Now, what was that? Excedrin headache number 7, whatever. There used to be a series of commercials, and they labeled different frustrating scenes as an Excedrin headache with a certain number.
I'm
And
gonna, at the end of this topic, please let me make a comment that happened on Saturday night. So,
okay, now this is the sponge move, Hyperion. It's uniquely shaped, irregular sized moon, known for its chaotic rotation. Um, it's perturbed by resonance with Titan and Saturn. It has a sponge-like surface. It's the largest known moon with such pronounced irregular gravitational interaction with Saturn's largest moon, Titan.
wow.
And I think
So
it also, its center of gravity doesn't correspond with its center of area.
that's right. It's not uniformly distributed. Now it
So,
tumbles and it rotates. So it's chaotic motion. I think we talked about that earlier. Oh,
yeah.
that was before we went on the air.
And did you have to work on problems like this, Jerry?
Yes.
Oh
I have a
God.
book here on chaos theory. In the 70s, there was a conference in La Jouche, France, on chaos theory, and it was one of the first conferences devoted to chaos.
Oh man.
Interesting topic.
Yeah,
Yes.
And,
broke out in
and
fist fights, Tim.
What's that?
It broke out in fist fights. It was so chaotic.
Yeah.
Yeah, yeah.
these crater looking things you see aren't really craters from impacts, a lot of them. The description I've read said they're more like sun cups that you see
Yeah.
in snow on mountains where there's a little bit of dark stuff here, these polycyclic aromatic hydrocarbons that get on it.
There's
Yeah.
that word
And
again.
and they absorb sunlight and they heat up and they melt their way down.
Yeah.
Oh,
So it's like if you have soot on snow,
Mhm.
and the sunlight hits it, it'll heat up the soot and the soot will kind of melt its way down into the snow.
hey
Yeah.
Chuck, is it ever possible for you to give me the symbol of that so I don't have to repeat that name?
Well, it's a generic term for a bunch of these benzene ring type hydrocarbon compounds.
Yeah.
Barbecue gunk is a good shortcut.
What is it?
Barbecue gum.
Barbecue gunk,
Barbecue gunk. I like it. Polycyclic
aromatic hydrocarbons.
aromatic hydrocarbon. Every time you say that, my brain kind of like freezes.
I was doing a talk up at, I think this was at Dunn School, to a bunch of sixth graders. And I was talking about, how they find these polycyclic aromatic hydrocarbons. And I happened to be talking about Saturn and its moons because there's a lot of that going on there with
Mhm.
the moon that has the double face, one
Iapetus.
side dark, one side light. Anyway,
Iapetus.
yeah, Iapetus. And so I kept saying polycyclic aromatic hydrocarbons. And by the end of the talk to these kids, I could just so, and we see lots of signs of, and then the whole class would go polycyclic aromatic
Oh, wow.
hydrocarbons.
That's kind of cool.
So
That's kind of cool.
this is the potato moon,
That's a good
Prometheus,
one.
small irregularly shaped moon,
Mhm.
notable for its role in shaping the planet's F ring. That's a way out there ring. Prometheus is known as a shepherding moon
Yeah.
because it gravitationally influences and constrains the F ring, preventing it from dispersing. It also produces waves in that F ring.
And Tim, its nickname is Spuddy.
It's funny. It looks like it looks like some kind of whale too.
Yeah,
Spuddy whale.
or a horse. I can see a horse with a salt nose.
It's got heavily eroded craters on it, I notice.
Hmm.
Yeah.
So it must interact a lot with the rings,
Yeah.
collision
It'd be
after
fairly
collision.
soft because they kind of fill in.
Yeah,
It looks real soft.
good crater back here, but none up here, so it must be going this way. Now this one is Daphnis.
Is that a hair on my No, that's in the image. There's a little
Yeah, this
squiggle
is
there.
a little bit of material that it's warped out of here. So this one kind of looks like it's a wave. Oh, this is the wave maker moon, not the other one that we just saw.
Well,
This is
the other
moon
one
makes
would do it
waves.
too.
Oh, did the okay.
And what this might be is debris from an impact on that moon.
Yeah.
Looks like
Yeah,
a
it
walnut.
looks very streamlined.
Yeah.
It
There's
looks
a
like
little on the other end as well. There's one on each
yeah,
end.
yeah. So this looks like one of the shuttles from Star Trek.
Huh.
So it grazes the inner and outer. It grazes. Let's see, the outer edges of Saturn's ring. Yeah.
Hmm.
So anyway, and this is our last topic of the day. This
Oh,
is a
Before
Go
before you
ahead.
go on the moons of
What's
Saturn,
that?
is this also on the rings of Saturn? I mean, on
No,
the
we're
moons.
new topic. This is
Okay.
a asteroid called
Last
Sylvia.
last Saturday night, there was a guy that came over, and I brought him over to Chuck, and the guy wanted to know if there was some kind of limitation of what makes a moon in the solar system. I mean, they wanted to know why is there so many moons on Saturn, and is it a size limit or whatever? And I think Chuck was saying, nope, not yet. So
It's going
so
to be the whole Pluto thing all over again.
yeah, so
Yeah.
I mean, there were, what is it, 241 or
274.
yeah, and but this guy was saying, well, why is it just keep increasing? And is there a limit? And Chuck was saying, not really.
When they start counting the ring particles, it's going to go up to billions.
Yeah.
Yes.
So that was my comment.
So this is a asteroid called Sylvia, and it's got two moons. And the interesting thing about these is that when you have three bodies mutually rotating around each other, you can determine a lot of properties of these bodies from the orbital equations. You measure the period and the distance and shape of the orbit, and so this data from this is that the primary Sylvia is 35% rock, 13% ice, and 52% internal voids.
Oh, wow.
Internal what?
Void, emptinesses,
Oh,
voids.
void.
Caves, caverns.
Right.
Oh,
Oh.
welcome back, Ron.
Yeah, thank you. I had a bathroom break there, gentlemen. Thank you for letting me go.
Okay, sure.
So these are orbiting each other, or the Remus and Romulus are orbiting, what do you call the
They
No.
are all three, they are each orbiting a common center of gravity, which is moving around.
Oh.
Okay.
It's because they're not that different in size and mass.
Boy, that calculation of the properties is crazy.
Yeah. So
That's your next math problem, Tim.
Oh boy.
so the main body consists of a pristine anhydrous outer layer and a differentiated interior with meltwater having percolated inwards so that the porosity of the rock is filled, that's the voids, with ice out to a radius of about 46 kilometers. The
Good
ice-free
grief.
porous rock above it is 104 kilometers radius.
But
So
it
that's
would
what you can tell about objects when they're in an orbital system and you measure the properties of the orbits. This is why they know that they're getting a ocean under Europa, for example.
God, man.
But this void, the rock is sort of like pumice here on Earth, isn't it?
Yeah, that's kind of be, but pumice dissolves in water. This is containing the water. It's not dissolving.
Hmm.
It's a fast rotator. It has a rotational period of 5.2 hours,
Wow.
giving a rotation. If you're standing on the equator, it's 65 meters per second, which has half the escape velocity from Sylvia.
Holy mackerel. When do
Mhm.
they deliver the mail?
Yeah.
So if we landed on this asteroid, there could be some interesting little trips inside through caverns, openings,
Yeah.
lava tubes, or whatever they.
Yeah,
But there'd be water in there too, frozen.
yeah, it doesn't have enough gravity to crush itself all together. So it's got a lot of cavities.
Now, Jerry,
Well,
are these calculations or something that you worked on as well?
I did not work on these. No, these are calculation published about these structures. Romulus was the first moon discovered in February 2001 by the Keck 2 telescope by Michael Brown and Jean-Luc Margot.
Good
Pluto
grief.
killer.
Yeah, right.
What's that?
Our
Pluto
hero.
killer.
Oh, that's right. Yeah.
Our
And the
hero.
second moon, Remus, was discovered 3 years later by Frank Marchus of UC Berkeley, Pascal Deschamps, David Hestrofer, and Jerome Berther of the Observatoire de Paris, France.
Mhm.
And once they had all the stats on all three of them, then they can go figure out, they can back out the internal structures of all these bodies.
I thought
And
Romulus and Remus were discovered hanging around Rome.
yeah.
Yeah, I heard that.
They're Shakespearean characters, but they are both asteroids themselves, aren't they?
You could call it that, yeah.
Yeah.
Probably captured by the bigger one.
Well, or they're probably pieces
Just got together. And
bigger collision that stuck together and ended up in this configuration.
it
These
looks
have
like a
been-
good place for NASA to visit someday. They're probably planning on it, I guess.
yeah, you have to be real careful to plan your landing so you don't end up joining some of the
Well,
debris there.
sometimes they just orbit. Check it out.
But these have been measured with occultations. Frank Marchus there is part of IOTA.
That's the group that Chuck belongs to.
Yeah.
Mhm.
The occultation timing group.
Yeah.
So all three of them occultate a star or just the big one?
Well, sometimes just the big one, sometimes just one moon. I don't know if anybody's gotten an occultation where they saw both moons at the same time.
Okay. I forgot the name of the big one again. What's it called?
Sylvia.
Sylvia. That's not hard to remember.
Yeah. Also
Well,
Shakespeare.
I'm back with a vengeance, and I guess we've exhausted incredible. Do they talk about this much stuff in an hour class out at Broida Hall? Do you suppose they probably just take any one of these and fill the whole
Yeah.
50 minutes?
They
don't
give
they?
you half of this stuff and then they ask you to derive the other half as homework.
So
Good.
your assignments guy. You want to give us that, Tom Whittemore, as like you used to do? Give us our assignments.
Yeah.
Wow. Well, all right. Well, let's do it again, including the cartoons. Till we meet again, everybody, next Monday, program number 233. I'd like to say check out our club website at sbau.org. And until we see you online again, here's how we say farewell in Astro Hour. Chuck.
Hasta Nebula.
Hasta Nebula.